An example of the inverse of a matrix is this. Let's say you have a 2 by 2 matrix A, which has entries 1, 1, 1, 2. And so it has inverse, this A inverse is a new matrix, which is 2, minus 1, minus 1, 1. And don't worry where I got this from. This we'll try to see where this comes from in future videos. But you can see that if you multiply A and A inverse, so what you get is the first matrix is 1, 1, 1, 2, and the second matrix is 2 minus 1 minus 1 1. So this is a 2 by 2 matrix, this is a 2 by 2 matrix, so the multiplication is well defined and the product will also be a 2 by 2 matrix. Okay, so we have to worry about the first row, first column entry. So I multiply this with this. So 1 times 2 is 2, 1 times negative 1 is negative 1, so 2 minus 1 is 1. 1 times negative 1 is negative 1, and 1 times 1 is positive 1. When you add together, you get a 0. 1 times 2 is 2, and 2 times minus 1 is negative 1, negative 2. The sum gives you 0. And 1 times negative 1 is negative 1, 2 times 1 is 2, negative 1 plus 2 is 1. So indeed you can see that when you multiply it from the right hand side, you get the identity matrix. This is the identity matrix of order 2. This is a 2 by 2 identity matrix. And you can also see from the other side, if you multiply A inverse A, we know from theory of matrices that these two might the product of two matrices, it is not commutative. This is not always the case, but these are special matrices for which this is true. So let's do this. This is A inverse. So A inverse is 2 minus 1 minus 1 1, and A is 1 1 1 2. So again 2 by 2 into 2 by 2 gives you a 2 by 2 matrix. So this is a 2 by 2 matrix. First row, first column entry, it's just 2 into 1, minus 1 into 1, that's 1. 2 into 1 and minus 1 into 2 is just 0. Negative 1 once, and 1 times 1 is 1, so the sum gives you 0. Negative 1 times is negative 1, and 1 times 2 is 2. So negative 1 plus 2 is indeed 1. And again, you can see that this is also the 2 by 2 identity matrix. So just it's a demonstration of this property of the special property of inverses, that when you multiply from either of the sides, you get the identity of that same order back.